Hello everyone. So my point is hierarchical clustering and dendrograms. So let's begin. So basically, hierarchical clustering is a type of unsupervised learning which means it groups data without needing predefined labels. The idea is to group similar data points together, but instead of forming just flat clusters, it creates a hierarchy of clusters. So, thinking just like a tree, at the bottom we start with individual points, and as we move up, they join into larger and larger groups. So, why is it useful? Because it gives us a clear picture of relationships within the data. Unlike the methods like k-mean clustering, here we don't need to specify the number of clusters in advance. The hierarchy itself helps us to decide. So, to visualize this particular process, we use a dendrogram. A dendrogram is a tree like diagram that shows at what distance two points or two clusters are merged. So, for example, in genetics, dendrograms are used to find similarities between genes based on expression patterns. So, now moving towards the particular concept description of hierarchical clustering, here we can see that the hierarchical clustering produces a tree structure of nested clusters, and there are two main approaches for this particular process. The first one is agglomerative clustering and the second is divisive clustering. So agglomerative clustering follows a bottom up approach. Here each point starts as its own cluster, and step by step the closest clusters are merged until only big cluster remains. And the second approach is divisive type of clustering, which follows a top down method. So here all points starts in one larger cluster, and then the cluster is split into smaller groups repeatedly until each point stands alone. So, in both cases, the result is a dendrogram. The dendrogram has a two particular axes. The x-axis shows the individual data points, whereas the y-axis shows the distance or dissimilarity at which clusters merge. So, for example, in marketing, hierarchical clustering can group customers by buying behavior. The dendrogram shows which customer groups are most closely related. So now let us look at this particular diagram to understand the difference between agglomerative clustering and divisive clustering. So here on the left side we have agglomerative clustering. You can see at the bottom all the data points are separate, shown as small colored clusters. As we move upward, these points are gradually merging into bigger groups. Finally, everything joins into one single cluster at the top. That is why it is called as bottom up approach. And the second type of clustering is, we can see that it is a divisive type of clustering. So, we have divisive type of clustering. Here, the process is the opposite. We start with one larger cluster at the top, then it is split into smaller and smaller clusters as we go down. So, finally, at the bottom, each point stands alone. This diagram clearly shows how the two approaches are exact opposite of each other. Now let us move towards the dendrogram, which is the main visualization of hierarchical clustering. So here on the x-axis we have data points, in this case customers. On the y-axis we have the distances or the dissimilarity we can say. Each time two points or clusters are joined, a horizontal line is drawn. The lower the line, the more similar the points are, and the higher the line, the more different they are. The most useful feature of a dendrogram is that we can cut it at a particular height to decide the number of clusters. For example, if we cut the tree at this middle level, we will get three clusters shown in three different colors. So, the most useful feature of a dendrogram is that we can cut it at a particular height to decide the number of clusters. So, if we cut it at the middle level, we will get three clusters shown in three different colors. This makes dendrograms a very practical tool for deciding clusters in applications like customer segmentation, gene expression analysis, and document clustering. So, now let us move towards what particular working mechanism does hierarchical clustering follows. So the particular steps in hierarchical clustering are starting with each data point as individual cluster. The second step is calculating the distances between all the points. The third is merging the two closest clusters. The fourth step is recalculating the distances between new clusters and remaining clusters. And the fifth step is repeating merging until only one cluster remains. And the last step is representing the merging process using a dendrogram. So, for calculating the similarity measures, or we can say the distances between that two particular clusters, we use distance matrices, which are similarity measures. So, the very first is Euclidean distance. So, the formula is given as d of x comma y is equal to square root of summation n over I is equal to 1 in brackets xi minus y square. So here x and y are the two data points and xi and y are their values in of the nth dimension. So n is the total number of features over here. So this formula calculates the straight line distances between two particular points. So here we can see that. So now moving towards the what particular linkage methods or cluster merging rules are applied over here. The most common distance measure is the Euclidean distance, which is simply the straight line distance between two points in n-dimensional space. But how do we decide which two clusters to merge? So this particular point or this particular aspect depends on the linkage method. There are the types of linkage methods or steps we can say. So the first is single linkage. So based on the closest pair of points between clusters, the formula is given. So the complete linkage, which is based on the farthest pair. The average linkage, which is used to calculate the distance between average distance between all the points. The Watts method, which is used to minimize variances within the clusters. So, for example, in the customer segmentation, the algorithm merges customers with similar purchase histories step by steps using the dendrogram. So, coming to what particular challenges does this particular hierarchical cluster follow is that it is computationally expensive. The time complexity is big of n square, which makes it unsuitable for very large data sets. Once clusters are merged or split, the decision cannot be undone. So early mistakes carry forward. Dendrograms can become difficult to interpret when the dataset is large. The tree may look cluttered. Finally, the results depend heavily on the distance metric and linkage method chosen. Different choices can produce different outcomes. So, for example, in e commerce with thousands of users, the dendrogram might become too so dense that it is hard to extract useful insights. So now, moving towards the summary of this particular PPT, hierarchical clustering creates a nested structure of clusters. Dendrogram gives us a clear visual interpretation. It works well for small to medium datasets. It does not require the number of clusters in advance, but the results depend on the chosen distance metric and linkage method. So, coming towards some important applications of hierarchical clustering, it is used in market segmentation to group customers with similar purchasing behavior. It is used in document clustering to organize articles or research papers. In sequence analysis, it is used to find similarities or dissimilarities among genes or proteins. In image segmentation, it is used to group pixels with similarity, color, or intensity. In social network analysis, it is used to detect communities. In anomaly detection, it is used to find unusual behavior. And lastly, in text mining and natural language processing, it is used to group similar words or items. So, this shows that hierarchical clustering and dendrograms are very versatile tools, widely used across wide domains. So, that's how I come to the end of my presentation. Thank you so much.